It's been a while since we've done a video on Octoprint, and I'm always learning new tips and tricks on how to better utilize it, so let's take another look. Hello everybody, Chris here, and if you don't know what Octoprint is, it is a very handy piece of software that you can use on a Raspberry Pi or other platforms to help monitor and control your 3D printer. And saying that Gina has done an amazing job developing Octoprint over the years is an understatement, as well as there being a great community surrounding it. And we really don't need another Octoprint Octopi install video. I have those. But I did want to take a look at the newer version of Octoprint as well as Octopi and show you some of the things that I do when I use Octoprint. A lot of times I use it to host multiple 3D printers, but I also have a method of keeping the image consistent, so if something bad happens, I can just swap out the SD card and continue on printing. And there's a few different pieces that go with that. So that's what we're going to do today. We're just going to run through end to end, and I'm going to show you my configuration of Octoprint and the multi-instance Octoprint, how I use it in my basement. So let's jump right over to the computer. When doing Octoprint, the first thing we do is head right over to octoprint.org. Here you can find everything you need to know about Octoprint, including a download page, a donate page, and a merchandise page. Again, this is great open source software, and I'm sure they appreciate your support. But let's head to downloads. And Octoprint is a program that can be compiled and ran on a Linux distribution, or you can use it as an image for a Raspberry Pi. And it's much easier to use that way, and we like to call that Octopi. That's the install we're going to be doing today. Now you'll notice the stable release is 0.17. Most of the time that is the one that I'm using, and it does support a lot of different hardware, including the Raspberry Pi 4. Now if you look below, we do have a release candidate of 0.18. And the main direction of this one is so that we can support 32 and 64-bit architectures. Once we get to 64-bit, things should perform a lot better, even on the Raspberry Pi. So in an effort to get my image up to date and just to try it out, I'm going to go with the release candidate of 0.18. You can go with .17 if you like. It's going to work pretty much exactly the same. This will take you to the GitHub. And I am going to go with 0.18, but I am going to stick with 32-bit. That might seem a bit counterintuitive, but I don't want to try to work out any bugs that there might be in the 64-bit version. So I'm just going to right-click and download this zip. Once that download is complete, I'll just go to Downloads, right-click, and Extract All. So the Octopi image is meant to be used on a Raspberry Pi, and that image is going to be flashed on an SD card. All of the storage that you have available for a Raspberry Pi lives on that card. And when you're purchasing an SD card, there's a couple things I like to look out for. This is the one that I typically use because I can get them pretty easily and they're fairly inexpensive. But you'll see that number 10 on the front of it, that's the speed of the SD card. Not all SD cards are created equal, and there are faster ones than these even, but a number 10 should do pretty well with Octoprint. Also, as far as the size goes, this is an 8 gig. I wouldn't go much over 32. You might want to partition it out if you do. But 8 should be more than enough for a couple of instances and some G-codes. Maybe 16 would be even better. But we'll go more over that here in a moment. Now with that said, this is not the SD card that I'm going to use to build my image. I'm actually going to use this old SD card right here. And there is a method to this madness. This is just an old school 4 gig SD card I had laying around. Don't really care what speed it is, I got time. But I'm going to use the 4 gig card to build the image because it's easier to store that image. When you boot the Raspberry Pi, Raspbian automatically increases the size of your card no matter what the image is. So you put the image on and it takes it to the max volume of the card. That's a pretty handy feature. But it can also cause some problems if you're trying to keep the image small. And you can't just flash the image because it will be too small. You won't have any extra room for upgrades or plugins like that. So you have to expand the card. So I'm going to build on this one, get the image, then flash the image over to my actual SD card. And that might not make the most sense. I'm going to expand on it just a little bit. But I'm using that 4 gig card because the Octoprint image takes somewhere around 2.5 gig to complete. But a 2 gig card isn't enough. You never see 3 gig cards, so we went with the 4 gig. And you can still get 4 gig cards, but this is the easiest way that I've found to be able to have an image that's somewhat manageable. If you use the whole card like an 8 or a 16 and you pull that image, then it's going to be 8 or 16 gig, and it's a lot harder to store and a lot harder to share. And I will make this image available if you would like to use it. So that's the reasoning behind it. Let's head back to the computer. So we're going to start with our 4 gig card to build our image. And usually before I use the cards, Win32 Disk Imager is what we're going to use to flash the image. It will format the card for you, but I do like to take a look at them in the partition manager just to see what's on them. And it might make this just a little bit easier to understand. So I'm going to come down to the Windows key. I'm just going to search for Create and Format Hard Disk Partitions. If you don't have this feature on your computer, you can go to Control Panel and install it. It's in the Windows programs. So now I'm going to plug in my 4 gig card. And there's no partitions on this, it's just one big block of space. And that's what we want to see. Now Disk Imager can take this and do whatever it wants with it. And I'll show you that after we make the image. So let's open Win32 Disk Imager. And there's a lot of programs out there that will do images. You can put them on whatever storage you'd like. I just like using Win32 Disk Imager because 1, it is free, and there's not a lot of knobs here, so it's kind of easy to explain, and I'm just used to using it. So that's what we're going to use, but you can use other things like Etcher if you wish. But we're just going to go grab that image file that we downloaded, this 1.8 image right here. We'll open it up. Make sure that we have our 4 gig SD card selected. E drive, that's the only one I have, and we're going to hit Write. It's going to ask if you're sure that you want to format that card because it's going to overwrite everything. Just hit Yes. Now, depending on the speed of your card, I told you about the number 10 on my Samsung card that I use for the Pi. This one's a number 4, so it might take longer on this older card, but not a big deal. We'll come back when it's done. And our write was successful. Now remember to go ahead and hit OK on this because it's not actually done until you OK it. And then we can get out of Imager for now, but we'll come back. And you can see in the Partition Manager, Disk Management, how it divided up that card. This is exactly the amount of space that that image requires. You have this boot partition, so you can read it in Windows and edit the files. Then you have everything in Linux. I believe they do ext3 on these. I don't remember exactly, but we can take a look. And then you have unallocated space. This is everything on the card that it didn't need from the image. So space that wasn't used. So you can see we have a almost 4 gig card. We have a little bit over a gig left. And I will come back after the fact, after we do the image of Octoprint onto the SD card, to show you what it looks like after it has expanded it. But our image write is complete. We do need to edit a few files. So let's go to our SD card. We wanted to go to the one that says boot because that's the one that is written in FAT32 so you can talk to it from Windows. And we need to edit octopi-wpa-supplicant.txt. I suggest you edit it with something like Notepad++. If you use regular Notepad, it might not work out so well. Now we need to enter our network and security information. We'll just take the comments off of these 4 lines. We need to enter our wireless network name. Remember, these are case sensitive. And your Wi-Fi password. Remember, it's case sensitive. And then down here at the bottom, by default, the Wi-Fi country code is United Kingdom. I'm going to put a comment on that. And I'm going to uncomment the one for the US. It's just good practice to go ahead making those changes. So that's all we need in here. We'll go ahead and hit save. And before we mount the SD on the Pi and boot up, I wanted to show you one more file, and that's the cmd line.txt or command line.txt. So let's open that up as well. And you can see this initialized script right here. This init_resize.sh, that's what does the initial resize of the SD card when you do the first boot. This actually goes away after that boot. This line isn't here anymore. But if you want to play around booting up without doing that automatic resize, this is the script you'd want to mess around with. But since we're using the 4 gig card, we don't have to worry about it so much because we can just keep it small on that 4 gig and let it go ahead and do the resize. We need a little bit extra space to get the full image installed with all the plugins we need. Just a note. Now we can unmount our SD card, load it on our Pi, and boot up. Now a lot of you probably already noticed that the Pi is going to use a micro SD card, and the 4 gig card that I showed you is a regular SD card. And that's not going to work directly with your Raspberry Pi, of course. I always like to have these SD to micro SD converters around. These are really handy on 3D printers and working with Pis, and they're pretty inexpensive. So that's how we're going to be using the 4 gig card just to get things configured for my image. But you could also try to find a micro 4 gig SD card if you wanted. So with the converter, just from the back of the Pi, the pins will go towards the PCB. Then we can load in the SD card with our image. Then we can plug in our power adapter and go ahead and power up and let it boot. You should have your red power LED, but if you have your green LED flashing, that's a good sign that it's able to talk to the wireless. And now is a great time for me to remind you that you need to use the proper power adapter for your Raspberry Pi. Use one that's meant to power a Pi, not a phone charger or anything like that. It needs to be at least 2 amp for the Pi 3, and it needs to be even more for the Pi 4, or it's not going to operate correctly. So you've been warned, I've said it a million times, but I thought it'd be worth mentioning it again. And if we got everything set up correctly, you should now be able to go to http://octopi.local. And here's our new image, ready to go with the setup wizard. I'm not quite ready to do that yet. I want to do a few other things, but we can access it. Now, these .local addresses don't work on every router. There's a couple things you can do to try to get it to work, but eventually you might need the IP address if you can't get them to go. So one thing you can try is to install Bonjour. You can see it here in my program list. Basically, that is just some file sharing services that might help these .local addresses to work. You can also install something like Angry IP Scanner and try to find the IP of the Pi, see which IP joined the network last, and try to figure it out that way. Or you can get into your router. This is my router and all the devices I have running on it. You can see all the different Raspberry Pis down here. And this one all the way at the bottom with a 254 address is the one that we just booted. Now, I keep track of my test Pi. I use the same one over and over, so I have assigned it an IP. You can assign them static IPs. You can also, in some routers, do a manual assignment. So anytime a MAC address comes in, the same one over and over will get assigned the same address out of the DHCP pool. And there's a lot of pieces and parts to explain with that. But basically, if you can't use those .local DNS names, you're going to have to figure out what the IP is. Just to further show you what I'm talking about, if you have a router and you can get into it, look for something about the DHCP server, and then something that talks about manually assigned IPs. You can see the one I'm using here at the bottom. I assign it a 254. That's so if I can't remember the DNS name, what it was called, whatever .local, what I changed it to, or I have more than one Octopi.local on the network, I can always find it. And we'll talk more about having multiple Pis on your network in a moment. And to just try to help you out even more, if you have Angry IP Scanner, put in your IP range. A lot of times it's 192.168.1.0 to 255, and then just start a scan. Look down through the list after the scan is complete. It should know that it's called Octopi. It's got port 80 and 443 open. Those are the HTTP and TTPS ports. And that's the IP. So then you can use that IP if the .local address isn't working. Hopefully one of these methods will help you out. Now that we've got some of that explained, there's a few things that I like to do when I build my image. I'm not going to do a lot of customization because I want to keep it somewhat vanilla, but I want to open up SSH on the Pi with Putty so we can enter a few commands. So I'm going to open up the Putty tool. Again, there's a lot of great SSH tools that you can use, a lot fancier than Putty. I'm just really used to using it, it's free, and I think it's easy to show people how to use it. especially users that aren't going to use SSH terminal all that much. So here in Putty, you can still use your octopi.local, and we'll just hit open. You might get an error, but on your home network, usually that's not a big deal. We'll just hit yes. And then we'll log in. Default username is Pi, all lowercase, and then Raspberry, all lowercase. Yes, it is case sensitive. And now we're logged in. Now the first thing that I like to do with these projects is I like to upgrade all the repositories and then do an upgrade of Raspbian, the OS that's underlying Octopi. Now this probably isn't the best idea to do on an existing install, but it shouldn't hurt too much if it's a brand new install. And before I make the image that I'm going to run with for a while, I like to be up to date. So I'm going to do sudo apt update. That will update all the repositories. You do need your sudo password, which is also Raspberry. Once that is complete, we will do sudo apt upgrade. And this will upgrade all of our packages. It'll give you a list of everything that's going to be upgraded. Hit Y, enter to tell it yes. And this will take a moment. And our upgrade is complete. We will need a reboot just for good measure. But before we do that, I wanted to take a look at the storage and just talk about it a little bit more. Since we're talking about partitions and SD cards, I'm going to do a df-h. And you can see right here, our root is 3.3, because that's probably actual space on a 4 gig card, how much we have used, and how much we have available. So it did the resize automatically, and I'll show you that from Windows as well in a moment. But if you didn't do the resize, you altered that init script or something, you would be around 93% used. So you really wouldn't have enough space to add your plugins or even do the upgrade. So that's why I used the 4 gig card method. So the next thing I want to do is start up raspi config. So sudo raspi-config. And I'm going to go to system options, number 1. And then go down to hostname, S4. This gives you advice on creating a hostname. You can't use certain characters. Just be aware of that. Hit OK. And you don't want to use spaces. But this is where it calls it octopi.local. That is the Pi's hostname. If you have multiples on your network, it's a good idea to change these. Make them something unique so that it can use a DHCP address, and then you can go directly to those names. There won't be 2 of them. If there's 2 on the network, it's going to get confused. Now for the image, I like to create it with something named image, so I know that I've used this image to build the Pi. And this also gets me away from, if I have another instance that's named Octopi on the network, things don't get confused. So I'm just going to name it Octo IMG. Just so I know it's an image. Now stay away from spaces, underscores. The underscore you can use in the URL, you just leave it out. It will find it, but it's better if you don't. So Octo image for this one, we'll tab down and hit OK. And we'll come back in here a little bit later to resize, but I won't show you that right yet. So let's hit finish. And we'll go ahead and let it reboot. Once the reboot is complete, then we can just go to our new name. So instead of octopi.local, we'll do octoimg.local. And here's our instance. We're at the wizard again. Now I'm ready to go ahead and proceed with the wizard. So we'll just click through, next. Here you can restore from a backup. Now the backup and restore feature in Octoprint is really handy, but you have to reset up the Octoprint instance to be able to use the backup. So if something bad happens, you can use that backup and restore on a fresh install. If you use the whole image, you don't have to have the backup. But it can still be handy. We're not going to restore from one right now. We'll hit next. Access control, go ahead and set up your username and password. Keep access control enabled. We'll hit next. Anonymous usage tracking, you can set this if you like, but it does help the Octoprint effort, so I do enable it. We'll hit next. Online connectivity check. This is mostly if your Pi is not connected to the internet. It won't waste resources trying to get to it all the time. So this checks to see if it can get to the internet. We can go ahead and enable it. Hit next. Plugin blacklist, just to be safe, we'll enable it. And the default printer profile, this is going to be generic for printer to printer because this is my image. There are a few things that I like to change on every printer, but the main one being the extrusion rate. I like to go from 300 to 100, even though this is millimeters a minute. It can get a little bit too high when you're trying to calibrate an extruder. I just like to lower it by default. It's my preference. So we'll hit next, and we'll hit finish. And remember, we're only changing things on this image that will be on every image. And if you scroll to the bottom, we are currently on Octoprint 1.4.2. There is a 1.5 version out there. So that's the next thing I want to do, is go to Settings, go to Software Update, and you can see Octoprint 1.4.2. There's a stable release of 1.5.2. So I'm going to go ahead and update that. And we'll proceed. After the update is successful, it will restart your Pi, or at least the instance of Octoprint, and then you can go ahead and reload. And now we're up to date on 1.5.2. Now let's talk about plugins. Plugins make Octoprint even more useful because users can create them to meet their needs. And there's a handful of them that I like to put on every instance of Octoprint, and I think they might be handy for some of you. So let's go over the ones that I like to use. We'll head to Settings, we'll go Plugin Manager, and then we'll hit Get More. Now these are in no specific order, they're just the ones that I really like. The first one being Resource Monitor. So we'll just search for Resource. You can go to the home page if you'd like details on it. But basically it gives you a view of what the Pi is doing at any time. And when you're running multiples, this can be pretty handy, so you know if you're starting to tax the Pi with multiple prints. It just makes me feel better to be able to go look at it and get a quick look and make sure that everything's okay. So we'll hit install on that one. And once installed, it should be in your tabs list or in your pull down over here. We'll hit Resource Monitor. It's just a quick dashboard to give you a look and see what's going on the Pi. Back to Plugin Manager. Next up, we're going to search for Navbar. And I like the Navbar Temperature plugin. It's just a quick heads-up display on the home page of the printer that you get the temperature of the CPU on the Pi, the tool, and the bed temp. It's just easy to browse through a bunch of tabs, check this one line just to see what's going on. So we'll install that one. And after a reboot, you can see those temperatures right up here at the top. We don't have a printer plugged in yet, so we're not getting readings for the bed or the tool, but they will be right here. This way, no matter what tab you're in, you can always see the temperatures up there at the top. Next up, I like Print Job History. We'll go ahead and hit install, and then we'll take a look at the details. But you don't know how handy it can be to have a history of how long a print took and what happened during that print, all in a list. If you do lots of tests, this can really save you. And this plugin comes with a lot of different pieces. I only use the job history, but there's a bunch of other things that you can do with it. When you install that plugin and it comes back up, you can see that it's offering you all these additional plugins that fit into print job history, like preheat, filament manager, all that good stuff. I do like display layer progress, we'll talk about that in a second, and Prusa slicer thumbnails. But just go ahead and disable this if you don't intend to install all of them, but those options are there, so we'll close this for now. And then we'll just open Print Job History. It defaults to the list of your print jobs, but there's all kinds of settings in this thing. If we go back to Settings, scroll down to Print Job History under Plugins, you can set it to how you want it to save. Print history only on successful prints, that's what I usually do. After every print, it's going to show you some dialogue at the end. I usually don't have it do that, but you can if you want. It has a lot of information that it will give you after every print. So I'm just going to uncheck this. But you can also go into Camera. You can set it to take a snapshot after the print's complete, so you even know what it looked like when you did the print. That will be included in the history. You can take temperatures from the preheat plugin. You can export and import your history if you'd like to carry it on to the next Pi. How it stores all the history, and then debugging info. But it's a great plugin, very powerful. Back to Plugin Manager. The next one I like to do, we just talked about it a second ago, but display layer progress. This can be a lot handier than you think. And after it's installed, you get a lot of this information up here in the nav bar, as well as down here in the printer state. It's going to give you the layer you're on and the current height. And if you're troubleshooting, things can start appearing at the same layer over and over, so now you have a note of where it happened. And you can kind of get an idea, if the print time estimates aren't quite correct, how soon the print's going to be done. I've really come accustomed to be able to see the layer height. I think it's a great feature. And of course, if you go into settings, there's all kinds of different things you can do with this plugin. There's an endless list of things you can tweak. But well worth giving it a try. And the last one that I really like is the Prusa Slicer thumbnail plugin, because I do use Prusa Slicer all the time. This one's just going to let Prusa Slicer send the thumbnail picture of the print when it sends the file over to the Octoprint instance. So we'll install it. Back to settings, you can take a look at the settings for the thumbnail, how you want it to scale, all that good stuff. You can actually rescan the files. If you install this plugin after the fact, just hit scan and it should pull in all those thumbnails. We'll take a look at that a bit more after we do the final install. And there is one more plugin that I forgot to mention that I do really like. So one more time, back to Plugin Manager. It's called Custom Backgrounds. What this one does is allow you to use an image behind your temperature graph. And that's all fine and good if you want to use an image on there, but I actually find it really handy to put the name of the printer that I'm using in that image slot. And it's really easy to do. And after that one's installed, you will have to reload. And I'm not going to show you how to set the image yet, because remember, I want to keep this vanilla to make the image. But that's all for the plugins. So now that I'm satisfied with the install and everything's up to date, I'm going to power down the Pi. Up here at the top, we'll just hit Shutdown System. I'm going to remove the 4 gig SD card and mount it back on the computer. And if we go back to that disk management tool that we were using before to create the partitions, now you can see we have the boot drive, and all the rest of the space is being filled up by the other partition. This is the partition where Linux lives. So that just shows you that the Raspberry Pi on boot is doing its job using the rest of the file system. But now I want to create an image of everything we've just done so I can use it later in case there's an accident. SD cards don't have the longest lifespan sometimes. So once again, I'm going to open up Windows Disk Imager. Only this time, I'm going to select a location where I want to store my image. I'm just going to browse to my C drive, and I'm going to call it octo_image_single. And we can hit open, and it's going to write to this file everything that's on the SD card. So just use the letter of the boot device, and it'll know what to do. You can see boot down here is E. And we're just going to hit read. And after a couple of minutes, the read is successful. We'll hit OK. And then we can go back to File Explorer. There's the image we created. We should have punched in the file extension, but we can go ahead and do that now. .img. It doesn't mean it won't work. It just means that Win32 won't recognize it off the bat. It's still a valid image file. And you can see it's just a little less than 4 gig. And you can see some of these other ones, these were images of 8 gig cards. So this does save you a lot of space in the long run. Again, I can share this a lot easier now if somebody else wants to use it. So that's the whole rigmarole with this 4 gig card. You don't necessarily have to do it. So now we have a good single image with all the plugins installed, so we don't have to redo a lot of that if we want to reload it on our SD card in case something happens to our Raspberry Pi. But as you've seen before, I like to do multiple printers on each Pi, so you have to have a multi-instance install, and I like to keep an image for that as well. So if something happens to my install, I can just use that image. I have all 4 of my instances ready to go, ready to plug all the printers back in. But things have changed in the new version of Octoprint and Octopi, so the install process for those instances is somewhat different. Now, I don't work with cameras very often, so I'm not going to show that portion today, but maybe we'll circle back later in another video and do that piece. But now, I'm just going to show you the new way that I found in this version to install multi-instances. So back to the computer, we're going to head back to Putty and log in SSH. And the multi-instance install is actually just a little bit easier in my opinion. You don't have to run around and make so many changes like we did before. So let's just start by taking a look in our home directory. Let's do an ls-als so we can see the hidden folders. And we have .octoprint right here. This is the base directory for Octoprint, so this is where most of the configuration information is going to be held. We just need to make a couple of copies of that. And I don't have a script that does all this for you yet, but hopefully I will very soon. And you can just run the script. You don't have to do all these different things that I'm going to do. I will leave all these commands in a doc in the description. But let's just make some copies. So since these are owned by the Pi user, we won't use sudo. We're just going to do cp.octoprint. We do want to use a -R so we get everything in that directory. And we're going to copy it to .octoprint 2. And we're going to do one of those for each install we want to do. So 2, 3, and 4. So now we need to create a service for each one of these so that we can start them on boot and assign a specific port for each one of these. The easiest way to figure out how to do that is to use sysctl and just look at the existing service. So let's do sudo systemctl status Octoprint. And here's the existing service that's already running, and it's located right here, octoprint.service. So we're just going to make some copies of those. So let's take a look inside there. We'll just do ls on etc systemd/system. Here's our service. And let's just make some copies of that service. So sudo cp, and then the location of the service, we'll just grab it from here. Octoprint.service, and we'll just go one more time. And just like before, we'll make a copy called number 2, number 3, and number 4. And on those, the new ones that we just made, we just need to make a few quick edits. There's not a whole lot in these files, actually. But we're going to do sudo nano to edit. And we'll just go to etc systemd system octoprint2.service. And we need to make a few quick updates. By default, the original instance is set to localhost 127.0.0.1. But it doesn't seem to work if you have multiples. You might be able to fix up the host file to get around this, but it's just as easy. I like to change this to all zeros. And then we need to use a different port number because the initial instance is on 5000, so let's just set it to 5001. We also need to point it at our new base directory that we created. So down here in xstart, we're going to start it in one of those other base directories. So we're going to do -- base dir equals, and then our directory location. We created those in /home, /pi, that's the user, that's the home directory we're in, .octoprint 2 for this one. And that's all we need to do. So we'll save this, Control X, Y, enter to save. Then we'll move to the next one. Change your host to all zeros. Update your port. We'll just make this one 5002. And add your base directory. -- base dir equals /home, /pi. And this one we'll stick on .octoprint 3. We're good there. Control X, Y, enter to save, and then one more for Octoprint 4. Same changes, change all your zeros. We'll increment this port to 5003, and we'll add our base directory. -- base dir equals /home, /pi, .octoprint 4. And we'll save this one. Now we only have to do one more thing. We have to get all of these enabled so they start up at boot. And you can do that with a one-liner, again with systemctl, we're going to do sudo systemctl enable, and then our new service names, octoprint2.service, 3.service, and 4.service. If you want to start them, you can just call it by its service name now. So we'll use sysctl, but sudo sysctl start, and then your service name, octoprint2. You don't need the .service. Octoprint3, and then octoprint4. And with all those started, we can head back to our browser, octoimage.local. There's our first instance. We'll duplicate this tab. And then after your local, we're going to do :5001. We can log in. They should be exactly the same as the first one. There's our next one. We'll do the same thing. Set this one to 5002. Log in. One more time. 5003. And there are all 4 of our instances ready to go with all of the plugins, so we don't have to redo them. And this is how I like to leave the image. So now I want to take another image snapshot of this 4 gig card before I move to the larger card, so I have an install image. I don't have to redo all this work again. So back to Win32 Disk Imager. I'm going to change the image name from Octoimage Single to Octoimage Multi. So we're going to go ahead and shut down our Octoprint instance. There is one thing that I thought of before we do this that I'd like to update on the image before I make a copy. If you go into Settings and then go to Server, these are all the commands that you use to control the service and shut down Octoprint. These don't get updated when you make the image. So this is the initial one, but I want to jump over to 5001 because that is where the Octoprint 2 instance is. So I'm going to go to Settings, go to Server, and I'm just going to tag a 2 right here. So that way if I want to restart the service, it just restarts this one, not the original service. So we'll save that. And same thing for the other ones. We'll go to the 5002. This is number 3. Server. We'll tag a 3 on there. And then the 4th one. Settings, Server, tag a 4 on here. I almost forgot about this. Now we're ready to shut down the Pi, remove the SD card, and make another image of it with Win32 Disk Imager. So let's come up here, shut down system. Now I've got the 4 gig card loaded, the one we've been building the images on. I'm going to open up Win32 Disk Imager one more time. We have our E card right here. Remember, use the one that's for boot. And I'm going to browse and stick this new image on C drive. And instead of single this time, we're just going to call it octo_image_multi. And we'll hit open. And now we'll just read it all over again with all the multi-instance changes. And now we have our new multi-image. So we'll just go ahead and hit OK. And we can exit. Now, what we want to do is get this image. We've already got one saved. We're done with our 4 gig card. Now we want to put it on a larger SD card. I've got my 8 gig. I'm just going to mount it on my computer. You can take a look. This is the new 8 gig card. It has partitions on it from a previous Octoprint install. I'm just going to delete these. You can just right click, delete volume. Again, be careful when you're in disk management. You don't want to hurt your main hard disk. So all the partitions are gone off of here, and I'm doing this so I can show you what to do. Now I'm going to load that image we just saved on my larger card. Back into Win32 Disk Imager. Again, we have our E device, even though it's the new card. I'm going to go grab that multi-instance we just created. This one right here. We'll hit open. And now we can write it on our larger media. And now our write is complete on our larger card. Let's go ahead and hit OK. We'll exit out of Win32 Disk Manager for the last time. We can refresh our disk management tool. And now you see we have 3 partitions. This is what the image looked like because we had it on a 4 gig card, these two. And then unallocated space. Now, normally on boot, Raspberry Pi, the Raspbian software would take care of this and just make it all one big card. So it would increase the space of the image so you could use the extra space. And if we go to File Explorer and we take a look at that boot directory, this is just added extra information. We go to command line.txt, take a look in there. If you remember, we had that init script over here beforehand, right out here to the side. We don't have that anymore because we've already gone through first boot. But don't worry, it's a pretty easy fix. So now we're going to unmount our SD card, our new larger one, and put it on the Pi. Our final micro SD card, our 8 gig card, that we built from the image. And we'll power up. Once it has gone through the reboot, you can go back to your web browser. Just make sure all your instances are still there. Our main one looks good. We can reset our 5001. It looks good as well. We should be okay. But we need to go into SSH and make one final tweak. We're almost done here. So back to Putty, we will log in one more time. And just for fun, let's take a look at storage, df-h. You can see root is still setting at 3.3 gig because of the old 4 gig image. We still have lots of space, but we want to use all 8 gig for the G code that we're going to put on here. And the Raspberry Pi config tool will do this for us. So do sudo raspi-config, go to System Options, go down to number 6, Advanced Options, and hit Expand File System. Root partition has been resized. File system will be enlarged upon next reboot. So that's good. We can go down to Finish. Use the Tab key in this menu if you don't know how. Would you like to reboot now? Yes. And once the reboot is complete, you can just go ahead and go into the GUI and see how much space you have. Down here under G code, it gives you a rough estimate. It does say 7 gig, but it's going to be 7 and change. But just to make sure, let's go into Putty and take a look at it so you know what to look for. And we'll check that storage, df-h. And there we go. Our root file system, 7.1 gig. We have 1.8 gig used. Now we have all the space on our card back. And we are done. Now there are some additional steps that you have to take to get the Raspberry Pi, the multi-instance install working correctly. You have to build your USB rules file, and I do want to show you how one of these plugins works real quick, just so I can show you what it's going to be like, because I think it is kind of handy. So let's do a couple more quick things. We are going to go edit our etc udev rules.d 99 USB rules file. This is how you map all of your printers to a specific device so you can rename it something. I'm just going to put in all these generic values. I'm going to copy and paste. All this information will be in the description. But these are all the different attributes you can use. If you've ever done a multi-install, you're pretty familiar with this. But as you plug in your printers, you can look in the messages file, and it's going to give you the ID vendor, ID product, dev path, all of this stuff that you want to use. I will leave a link to a timestamp in a video that shows you exactly what to do when you set these up. But just beware, you're going to have to build one of these files. So we can save this for now. And for the last thing that we do today, let's check out some of those plugins real quick, since we have everything installed now. First off, let's start with that Prusa Slicer plugin, where you can see the thumbnails. So let's just head to Prusa Slicer, and let's just slice something real quick for a test for the Mini. This should work on any printer, but we'll slice it, and then we can send it over to that Octoprint instance if we have the API key. So let's go back there real quick. We'll go to Settings, get the API key, and just a note on this notification up here, you should no longer use just the global API key. It does still work. Best practice would be to create a user ID for each application that you wanted to access your Pi. It's not real dangerous inside your home if nothing's exposed to the internet. Just be aware of that those settings are there now. You can assign an API key per user ID. but we'll go for the global for now just for this test. Back to Prusa Slicer. In printer settings, we can set the name of the Pi or the IP. So we can do octoimg.local. And if you want to use one of the other instances, just put a :5001, just like you would in the URL bar. It works the same, but we're going to use the main one for now. And then we'll paste in our API key right there. You can test it. Connection works great. So we'll send that over, slice, and then send, and then back to Octoprint. Here's our file down here, and you can click the Show Thumbnail button. And there it is. You can also set it so it shows it off to the left of the file name. They are kind of small, but I think this is a really cool feature to have. Sometimes I name these files and I don't remember what the file actually was. Being able to see the quick thumbnail really helps me stay organized. Now let's take a look at that background plugin. We'll head into settings. We have this custom background plugin, and I think these are really handy. You can change how the image is seen, whether it's auto to fill the whole screen or the center section. I'm just going to leave it default so I can show you what it does. But it allows you to overwrite this image here in the temperature section with an image of your choice. And you can use a picture or whatever you might have, but I think it's handy just to have a quick look at what printer you're using, or maybe what location that printer is in. So if you have multiple Ender 3s and you've got one on the top shelf or on the bottom shelf, I like to put that information right here. And it's really easy to do. So whatever graphic editor you want to use, I like to use GIMP. I usually just create a new 800 by 600 image. And we're just going to make it really simple. But we'll grab some text. Let's just say this is for an Ender 3. And I'll make it pretty much fill the center of this square. You can make these as complicated or as simple as you want. I'm just going to save this off as a JPEG. Just export. We're going to call it ender3.jpg. Make sure that JPEG or PNG or whatever you use is in lowercase, or this plugin doesn't tend to like it. So we'll export. And then wherever you save that JPEG, you can just drag and drop it like you would a G-code file. So we'll just drag it into the window, upload locally. It's going to restart the UI. You can see the JPEG down here. And it did put it up in the window, although it is a little big. You can adjust that back in settings. We'll just switch it to contain. We'll hit save. And there we go. Now it's better sized. You can adjust the size in your program when you create it, or you can move it around in here, whatever you want to do. But I really like these when I have multiple machines, so I can label it, this is the one on the left, this is the one on the right, just so I know which one's which. I think it's a little easier to see even if you rename it or recolor them up here in the window. I just like being able to see it large, maybe even from across the room if I get the font big enough. And I think that's more than enough Octoprint goodness for one day. And that's how we Octoprint in the basement. Now, a lot of this information you've seen before, but hopefully you picked up a few tips, or you saw some plugins that you might want to check out. There are a few things that are different in the new versions of Octopi and Octoprint, especially when it comes to the multi-instance install. And I will go back over that in further videos so we can add in the camera stuff, but this should get you started if you've installed multi-instance before. So hopefully you found this helpful. That is it for today, and I will see you on the next one.